Hello. Hello. Can you hear me?
Good afternoon, sir.
Yeah, good afternoon. Okay, so we'll continue with the problems. This one was the first one, right?
Yeah,
So we have to find the bounded region of inequalities here, these three inequalities. So we'll try to draw the graph. So x is greater than 0, this region, and x plus 2y is greater than equal to 0. So first, we can draw the graph of just x plus 2y equal to 0. So that is basically y is equal to minus x by 2. So it will be somewhat like this. So this is the graph, passes through 0, 0, and at 2, y is minus 1. So at 2, x is equal to 2, y is equal to minus 1. And we have to find the region where the sum of x plus 2y is greater than equal to 0. So it will either be this region or it will be this region, right?
yeah,
So if you check 2 comma 0, for example, 2 comma 0 point, right? If you put
yeah,
that here, 2 comma 0 is greater than 0. So this is satisfying. So it is the upper region, right?
yeah,
And then similarly, 2x plus y is equal to 4. If we plot, we get x by 2 plus y by 4 is equal to 1. So x intercept is 2, y intercept is 4. So it is like this, right?
yeah,
So this is my graph. Again, less than equal to 4. So if you take any point like this here, like this is 0 comma 4, so you can take 0 comma 3 and check 0 comma 3. If you check, it is less than 4, right? So it is the lower region below the straight line, correct?
yeah,
So now if you have to take the region which is positive x and this, then it will be this region.
yeah,
So vertex of this region, I think, should be this point, right?
yeah,
So you just solve these two equations. So you get 2x plus 4y is equal to 0 and 2x plus y is equal to 4. So you get 3y is equal to 4. So y is equal to 4 by 3 and 2x is equal to 4 minus 4 by 3. So 8 by 3. Right. And so x is equal to 4 by 3.
yeah,
And 4 by 3 comma 4 by 3 as the vertex here. Now, no options are there. Okay? So no options are matching. That means I think something is wrong then, because there's nothing wrong with our solution. Does he mean 0 comma 4 or something? No.
maybe because they have repeated option B and D. So,
Something is wrong. Okay, don't worry about it. This is the way you have to solve it. You have to plot the region. This is the right region. Correct.
yeah,
There is something wrong with the options, I think. So, yeah, we will not spend too much more time on this. It's pretty easy only. The next one is, one second, this one. 43, minimize this subject to this condition. Linear programming, this is in
yeah.
this linear programming.
Sorry?
Is this in the syllabus in NCERT?
Yeah, it's there in NCRT. I'm not sure about this particular topic, but like the chapter is there in NCRT.
Mm-hmm. Minimize. It is definitely not in JEE syllabus, but this is for KVP, right?
Yeah.
I is equal to 1 to M Cij x ij. You have to minimize Z subject to the conditions. Subject to conditions. Sum of j is equal to 1 to n xij less than equal to ai. I goes from 1 to n. Summation j I is equal to 1 to n xij is equal to bi. J is from 1 to n. Is a linear programming problem with a number of constraints. You have to find how many constraints are there, right?
Yeah.
So we have to basically count the number of constraints here. So if we think about this equation looks like x I1 plus x I2 plus so on till x in less than equal to ai, and then I goes from 1 to m, right?
Yeah.
When I is 1, there will be one equation. So there will be basically m constraints here, right?
Yeah.
Because there will be m rows like this, m different equations, right?
Yeah.
And here, if you say it is x1j is equal to bi, so I is 1, and similarly x2j is equal to b2, and so on. There will be equations will be like basically m terms here. Xmj is equal to bm, right?
Yeah.
And then for each j, you have 1 to n. So here you will have x11 is equal to b1, x12 is equal to b1, right?
Yeah.
So n terms here and m terms here, right?
Yeah.
Nm total constraints here, right?
Yeah.
So nm constraints are coming here, and here there are m constraints. Is it like, are there some common ones or something? That is what you have to think of. Wait 1 second. So x12 is equal to b1, x11 is equal to b1. Basically, it's like saying all of these x11, 1j is b1. So here also you have x11 plus x12 plus x 1n less than equal to a1, and this goes on to xn1 m1 plus x m2 plus x mn less than equal to am. This is the set of equations here, and here you have equalities. So all the x1s will be b1, all the x2s will be b2 and so on. So this goes on to x n x1 and j goes to n 1n. This goes to x. Basically, this vertical column goes from x11, x21 till x, no, 1, 2 till 1n, right?
Yeah.
And all of it is b1, b1, b1. So this is like saying this is the same set of terms, no? See,
Yeah.
1, 1, 1, 2, 1n, right?
Yeah.
So you are saying basically, if you use combine both the constraints, you're saying that n times b1 is less than a1, right?
Yeah.
N times b1 is less than a1. And similarly, 2, 1, 2, 2, those will come in the second row, right?
Yeah.
So if you combine these two constraints also, you'll get another equation, n times b2 is less than equal to a2, right?
Yeah.
So you totally get m constraints only, right?
Yeah.
Like it looks like many, but actually you can combine.
Yeah.
You understand what is happening.
Yeah.
All of these rows are actually these vertical columns. You can combine them and write one equation, and there are m rows. So total m constraints, right?
Yeah.
But he's giving options of m plus n and all. So then what is the mistake here? What is the answer given?
M plus n.
Why m plus n? It feels like we combine stuff. Hmm, m plus n. Okay, we have not thought about the maximizing part, minimizing this part. We have just looked at the constraints so far. So we're getting m here, and we have b1 to bn, right? We have
Yeah.
b1, b2, bn, and a1, a2 till an. No, this is going on to go on till bm. So bm to an am. Last term will be bm less than equal to am. And we have to minimize this thing. So not sure what they want here. Linear programming you have studied. What is the theory here? Like, have you done the chapter?
Yeah, we have done the chapter, but like from NCRT, it is
Uh,
usually just the graph part, the vertex is,
hmm.
and the maximize and minimizing the function, we just substitute the value of the vertices and whatever is the least value. That's the most
Hmm. Okay, I'm not sure about this, like because I feel like there are m
we have
constraints.
done.
Hmm. So right now I feel like there are m constraints here, but after that, this minimizing part here, if we rewrite it a little bit, we might get many equations here actually. Like first you can substitute all the i's here. It will be c1j x1j and plus c2j x2j, right?
Yeah,
Till cmj xmj. And then you have to substitute the j's.
yeah,
J goes from 1 to n. There might be many equations here, like j goes from 1 to n and I goes from 1 to m. Cij xij is basically summation j goes from 1 to n. This looks like 1j x1j plus c2j x2j and cmj xmj. And then when you sum it up, you can write it in columns like this: C11 x11, C12 x12, C13 x13 till C1n x1n, and similar columns everywhere, right?
Yeah.
We have to 21 x21 and so on. We have to minimize the sum of everything. So then maybe what they mean is we already have a relation for the addition of all the xi's, right?
Yeah.
1 second. C22 x22, and here to CM J is varying, so M1 next M1, and here it will be CMN XMN. So we have to minimize the sum here. We already have equations like NB1 is less than equal to A1 and all. NBM is less than equal to AM. Can we use that somewhere here? Summation of the C is a new parameter to not even there in the earlier one, in the constraints. Not sure, like we'll have to look at the theory here before we can do anything. You should ignore it. Like if a question like
Okay.
this comes, you can skip it, I think. You will have to spend a lot more effort on trying to figure this out than is valuable at this stage. So
Yeah.
I'm not sure. I have to look at the theory. The next one is this integral.
Yeah.
Okay. Integral of x bar x 1 plus log x dx. Okay, so first I need to know the derivative of x bar x, because otherwise I will not be able to think of any substitution, right? So
Yeah.
if f of x is x bar x, I will take log, and log f of x is equal to x log x, and differentiate 1 by f of x, f dash x is equal to log x plus x into 1 by x, right?
Yeah.
So f dash x is equal to f of x into log x plus 1, right?
Yeah.
So this is the thing, right?
Okay. Yeah.
This is just the derivative of this, right?
Yeah.
So d by dx of x bar x dx integral will be x bar x, right?
Yeah.
Basically, the idea is the function itself is so weird that you should check the derivative once. X bar
Yeah.
x is not a normal function. So normal techniques will not work. You have to think of whether you know the derivative of that or not. So that is that. Then the other integral is integral of x plus x to the power 2 by 3 plus x to the power 1 by 6 divided by x into 1 plus x to the power 1 by 3 dx, right?
Yeah.
Okay, so Normal things to think of here in such questions is to think of x as some power of t, right? If you think of it as an
Yeah,
appropriate power of t, it might cancel all the fractional powers, right?
yeah, I had tried that. I tried taking x as t power 6 because,
Hmm.
but in
Didn't
the
work.
end, it did not work out.
Maybe let's see once. If you try this, what happens? It becomes t power 6 plus t power 4 plus t, right?
Yeah,
Multiplied by 6 t power 5 dt divided by t power 6 1 plus t square,
yeah,
right?
yeah,
Okay. Correct. So we have here degree 8 here and degree is higher on top, right?
yeah.
So we can remove t power 5 here and write it like this and say that,
We can remove that t as well, right?
and that t also. So it will become t power 5 plus t power 3 plus 1 divided by 1 plus t square, and 6 comes out, right?
Yeah,
Okay. So this thing, the best way to do it is take common t cube. It is 1 plus t square plus 1. It's over, no? You understand? It's done.
okay, okay, yeah.
See, if the numerator has higher power, right?
Yeah, long division usually works.
You should just divide it and separate it out and take the remainder part. Only the remainder part is the tricky part to integrate, right?
Yeah,
So here, though, it is obvious to take common t cube. That it becomes t cube plus 1 by t square, and then you get t power 4 by 4 plus tan inverse t,
yeah,
right?
yeah,
So if you know the correct technique, then you have to trust that it will work. Maybe you did not look at this carefully.
yeah,
It's higher power in the numerator. You just have to divide, right?
yeah,
Okay. Then there is this other integral, sec power 2 by 3 x cosec power 4 by 3 x dx. So first convert everything to sine and cos because that's easier to think. 1 by cos power 2 by 3 x and sine power 4 by 3 x, right?
yeah,
Then I want tan and all somehow. So if I multiply, if I just write a cos power 4 by 3x here, I have to write a cos power 4 by 3x here, right?
yeah,
Correct.
yeah,
And this and this become cos square, right?
yeah,
That becomes sec square x on top and tan power 4 by 3x on the bottom, right?
yeah,
So now it is done. Integral dt by t power 4 by 3, right?
yeah,
So it will be t power minus 1 by 3. Uh, yeah, that's it. So minus 1 by 3 by minus 1 by 3 plus c, right?
yeah,
So minus 3 tan x power minus 1 by 3 plus c, correct?
yeah,
So again, converting to cos and sine is a standard step. After that, you have to look for making it into a tan because that is usually how these types of integrals work. So how do I make it into a tan? I need a by 4 by 3 here. So I have to multiply by this.
yeah,
Okay. So that is the last of that day's problems, right?
yeah,
Um, okay, so then this one is, next one is, a ball is dropped vertically from a height h onto a hard surface. Ball rebounds from the surface with a fraction r of the speed with which it strikes the latter on each impact. What is the net distance traveled by the ball up to the 10th impact? Okay. Ball is bouncing. When it comes up, it has speed of RV. If it had speed of V while hitting, right?
Yeah.
It dropped from a height h, comes up with speed RV, right? So what is the height it will go now? That is what you have to figure out, right? H dash, right?
Yeah.
So that is pretty straightforward. So we say that if RV is the initial speed, you will have finally 0 is equal to R square V square minus 2G H dash, right?
Yeah.
H dash is R square V square by 2G, right?
Yeah.
Correct.
Yeah.
So it will go that much and then that much. So 2H dash distance, right?
Yeah.
2H dash distance, and then the speed will become R square V, right?
Yeah.
And the height now, H double dash, would be what? Height now would be, instead of RV, we have R square V. So it will become R power 4, R power 4 V square by 2G, right?
Yeah.
Same way like we did here.
Yeah.
You understand?
Yeah.
Then the distance traveled will be plus 2H double dash.
Yeah.
This is first collision. This is second collision. This is third collision, right?
Yeah.
Correct. And high total distance traveled is this, right? And
Yeah.
we have to find distance traveled by the ball up to the 10th impact. So up to the 10th impact means
Counting the ninth one.
counting the ninth one. Ninth one you have to go up, go down. That will be 10th one, right?
Yeah.
So we have to just see a pattern in this, right?
Yeah.
In these ones, these will be some GP sort of a thing, right?
Yeah.
So if you write this as R square V square by 2G, next one as R4 V square by 2G, then you can see the pattern. It will be R6 V square by 2G and so on, right?
Yeah.
This is second, this is third. Third is this, right? So fourth is R6. So ninth one would be 8
Uh,
into 216, right?
yeah.
Right.
Yeah.
So, and the first height is whatever h, right?
Yeah.
Um, we have not multiplied by 2. We have to multiply by 2 in every step, right?
Yeah.
Correct.
Yeah.
So initial h will be equal to h and v will be related, right? Initially, because you'll say v square will be 2gh, right?
Yeah.
So h is equal to v square by 2g, or we will use this v square is equal to 2gh to remove all the v's later, right?
Yeah.
So I have this series right now. I have to add it up, and I can take v square by g common, and it is r square plus r power 4 till r power 16, right? Correct.
Yeah.
So that
Yeah.
becomes, there are how many terms? There are 8 terms. So common ratio is r square. Then you have 1 minus r square power 8. So 16 by 1 minus r square, right?
Yeah.
Correct.
Yeah.
Term is r square, 1 minus r square power 8 by 1 minus r square, multiplied by v square by g plus h, right? And v
Yeah.
square by g is equal to 2h, right? Correct.
Yeah.
So v
Yeah.
square by g is 2h. So you have h plus 2h r square, 1 minus r power 16 by 1 minus r square. So you can take h common and all. Travel net distance traveled by the ball to the impact. Okay. H common, you have 1 plus 2r square, 1 minus r power 16 by 1 minus r square, right?
Yeah.
So this becomes 1 minus r square plus 2r square minus 2r18 by 1 minus r square. So this is becoming 1 plus r square minus 2r power 18 by 1 minus r square h into. Uh, mm, are we counting the collisions correctly? Like it's now a question of like doing the summation carefully. 1h, this is first collision, then h dash, h dash, second collision. Feels like we are doing it correctly only, right?
Yeah.
Rv was the speed, so height will be r square v square by 2g, 2h dash will be this. Next time it will become r square v r4. Everything seems correct. Till the end, have we counted the
Won't we start with the
hmm,
v square by g instead of starting with r square v square by g?
we are starting with v square by g. This is h, right? H was v square by 2g actually, right?
Yeah.
And after I'm counting the series from the second onwards.
Yeah.
Just check the calcul. It's a calculation question now. The physics part is obvious, right?
Yeah.
Like just check the calculations or see the solution. Like maybe we have made some silly mistake, but there's no mystery to it, right?
Yeah.
Just check it once, solutions and all. This is what you have to do. You have to be aware that velocity keeps becoming smaller and smaller, and therefore height will depend like this. And you have to just count it properly.
Yeah.
Okay. Uh, then we have this one. A certain planet, this one. So a planet completes one rotation in time t, in time capital T. The weight of an object placed at the equator on the surface is a fraction f of its weight recorded at a latitude of 60 degrees. So, okay, this is a planet. The weight at the equator, right? So m g dash, whatever is this effective gravity, right?
Yeah.
Weight at the equator, w, is a fraction of the weight at 60-degree latitude. F time W dash is equal to F time W. This is W, let's say. Weight here, right?
Yeah.
And we have to find out density of the planet. Correct.
Yeah.
Okay, so what we need to figure out is how does your weight vary with different latitudes, right?
Yeah.
So technically what will happen is when you are at a higher latitude, here, let's say, this is the center of the planet, the force of gravity will be along this direction, right?
Yeah.
But the centrifugal force will be along this direction, right?
Yeah.
Because you're going on a circle like this, right?
Yeah.
So this is centrifugal force or centripetal acceleration, right? So m
Yeah.
omega square r, and this is your g, force of gravity, right?
Yeah.
And as a result, the two resultant forces will have some resultant Fr, and that will be what your normal force will oppose, and that will be your weight, this, right?
Yeah.
So you understand this, no?
Yeah.
So basically, you can even put this in the opposite direction, because you can say that I am on this frame, which is a rotating frame or a non-inertial frame, and I can put m omega square this direction, and Fg is like this, and the resultant force is this. Normal force will be opposite to that, right?
Yeah.
So now, if you do the resultant of these two forces, m omega square r, and actually I should not put m omega square inside. I should put it in the opposite direction because I am on the rotating frame. So m omega square r is this side. It's a non-inertial frame, so I have to put a centrifugal force, right?
Yeah.
Now, this force, let's say, is mg, because it is on the surface of the earth, so mg will be the gravity attraction, right?
Yeah.
And this angle is 60 degree, right?
Yeah.
So we have 120-degree angle here, right?
Yeah.
So 120-degree angle here. So what is the resultant of these two forces? That is your effective gravity. So resultant would be root over mg square plus m omega square r. R is different here, right?
Yeah.
Correct. You
Yeah.
know why R is different is this R, right?
Yeah.
So total radius cos 60, right? So R by 2, right?
Yeah.
You understand that this radius is R by 2 here.
Yeah.
So this is R cos 60. M omega square R by 2 whole square plus 2 mg into m omega square R by 2 cos 60, cos 120, right?
Yeah.
That is the resultant. So minus half. You understand?
Yeah.
This is coming out. This is my weight at the point here, W. Okay.
Yeah.
So if we put it, if we simplify that a little, m square g square plus m square omega power 4 r square by 4, and this becomes minus half m square omega m square g omega square r, right?
Yeah.
This is the value of my, 1 second, let me just think. There is no calculation mistake, no? M square g omega square r, correct, right? Yeah, makes sense. So this comes out to me my W, right? And at the equator, it is much simpler. Centrifugal force is this direction, weight is mg this direction, right? So effective resultant is this direction, which is mg minus m omega square r, right?
Yeah.
So in this case, I get simply this expression is my W dash, right?
Yeah.
There is nothing to do because here capital R is also capital R only, right?
Yeah.
So W dash is equal to F times W. That is what is given, right?
Yeah.
This was my W at 60 degree. This is my W dash here. It is F times W, right? Correct.
Yeah.
So we'll simplify that by squaring, and we will see that we get mg minus m omega square r whole square is equal to this thing, m square g square plus m square omega power 4 r square by 4 minus half m square g omega square r. So m square g square here plus m square omega power 4 r square minus 2m square g omega square r, right, is
Yeah.
equal to this. This cancels this term. This comes this side, it becomes 3m square omega power 4 r square by 4 is equal to this goes this side, 2 minus half. So that becomes 3 by 2 m square g omega square r, right?
Yeah.
M square cancels, omega square cancels, becomes omega square here, r cancels. So we have omega square here, r by 2 is equal to g here, right?
Yeah.
So now omega is actually 2 pi by time period, right?
Yeah.
Now the density of the planet is being asked. Okay, fine. So now this g that we have used is actually g capital M by r square, right?
Yeah.
Correct.
Yeah.
We have this relation right now, which means just instead of omega square, I'll put 4 pi square by t square, right?
Yeah.
2 and r is equal to capital G, and mass can be written as density into volume. So density into 4 by 3 pi capital R cube by capital R square, right?
Yeah.
We need density. So this R square, R cancels, 4 cancels, pi cancels, and we get 3 go, everything is cancelled here. 3 goes this side, 3 pi by 2 g t square is equal to rho, right? Right.
Yeah.
Wait, I forgot about the F. Everything is wrong now because I forgot to put the F. You understand
Oh.
what I'm saying?
Oh. Okay. Yeah.
When I squared it, I should have put F square omega square now. Right?
Yeah.
So just I have put equal to, that's why it is coming wrong. But to understand what the problem is about.
Yeah.
So at any, let's do it in general, at any theta here, right?
Yeah.
Gravity force is this direction. Because you're going in a circle, you will have a centrifugal force of this direction if you're looking from the frame of the person standing. That will be m omega square r dash, and r dash will be r sine theta, right?
Yeah.
And this force is mg, where when I say mg, I mean g at the surface of the planet, right? Which can be written as gmm by r square, basically, right?
Yeah.
So the resultant of these two forces gives the net effective gravity. That is the force of gravity effective, right?
Yeah.
So this is the weight of the of at this point. So how do you calculate that? You take resultant force of F resultant is equal to root over this mg square plus m omega square r sine theta whole square plus 2 mg into m omega square r sine theta into the angle between these two forces. So this angle will be, if this is theta, this is theta, so this is pi minus theta, right?
Yeah.
Cos pi minus theta would be minus cos theta, right?
Yeah.
So this force would be your effective weight. At the equator, you will see that theta is 0. So this term vanishes, right? Correct.
Yeah. Yeah.
And theta is 0. So at the equator, am I making some mistake here? 1 second. Uh, am I writing the thing r cos theta? No, this angle is theta. It's r cos theta, right?
Yeah. Yeah.
Right. It is r
Yeah.
cos theta. So everywhere here cos theta, and here also cos theta, right? Now it
Yeah.
makes sense. So at the equator, it becomes mg square and plus m omega square r whole square minus this cos and all becomes 1 minus 2 m square g omega square r, right? Correct.
Yeah.
And if you see that, you will realize that that is the whole square of mg minus m omega square r, right?
Yeah.
Right, because this 2ab term is this one, right?
Yeah.
So at the equator, your thing becomes f resultant becomes simply mg minus m omega square r. If you put theta is equal to 90, this term will disappear, this term will disappear, and you will get only mg at the north pole,
Yeah.
right? So this formula will work whenever, like, just make sure you're writing the correct this term and just doing the resultant normally, how you do resultant of two forces, right?
Yeah.
Now in this question, you have to say that this resultant force at 60 degree is equal to F times this resultant force, right?
Yeah.
I forgot to put the F. So after that, you'll square it and all, and you'll get things in terms of F, right?
Yeah.
At the end, you have to put the fact that mass capital M is 4 by 3 pi r cube into density. And from there, you will get an equation for density, right?
Yeah.
And omega is basically 2 pi by time period.
Yeah.
Are you understanding what is happening?
Yeah.
Okay, so just do it yourself now. It should be just a little bit of calculations.
Yeah. I'll do that.
Then there is a planet orbits in an elliptical path of eccentricity E. There's an elliptical path. This is a star. Eccentricity is E. It is fixed at this foci. The point in space where it's closest to the star is this point P, and the point where it is farthest is this point A. At Vp and Vb with respective speeds, Vp and Vb, Va. You have to find the ratio of Vp and Va. This is pretty straightforward. No?
Yeah. I tried the angular momentum, conservation of angular momentum. So with that, I got the answer as option A, but they have gotten the answer as option B. So I was confused. I was like, did I do something wrong?
Okay, so angular momentum should be conserved about this. So MVR should be MVPRP should be equal to MVARA, right?
Yeah.
So you have to find VP by VA. So VP by VA is simply RA by RP, right?
Yeah.
So RA is this distance is basically AE plus A, right? But you are correct only. I don't think there is anything wrong. A1 minus E, right?
Yeah.
To be 1 plus E by 1 minus E. There is no mistake here. Like the It is a printing mistake or something.
Okay.
One second.
Yeah.
Let's check it once more. Point to it is farthest. Yeah. There is no mistake here. VP and VA will be in this ratio. Angular momentum conservation is the right thing to do. Yeah, nothing else. Yeah, this is correct. Okay.
Yeah.
And so get more doubts and all, we can discuss again. When is your next exam?
20th.
So there is time then.
Yeah.
Okay. I'll see you next class then.
Thank you.
Bye.